Galileo's discovery that Jupiter has moons proved that the ancient belief in Earth as the center of everything was not correct. However, by itself, it did not demonstrate that anything actually orbits the Sun. That changed when Galileo turned his telescope to Venus. This video will give you the chance to reconstruct his chain of reasoning. To start, let's review how Venus appears in our sky. During the times when Venus is visible, it shines brightly, either in the dawn sky, rising ahead of the Sun, or in the evening sky, following the Sun down. At other times, Venus appears so close to the Sun that it is lost in the Sun's light. Ptolemy's Earth-centered model used two features to explain this behavior. To account for the fact that Venus always remains close to the Sun in our sky, it assumed that Venus and the Sun both move around Earth in tandem. To account for the fact that Venus is sometimes ahead of the Sun and sometimes behind it, the model used the same idea it used for all the planets. Venus moves around a small circle at the same time that this circle orbits Earth. When Venus is slightly ahead of the Sun, we'd see Venus in the morning sky, and when it is slightly behind the Sun, we'd see it in the evening sky. To the naked eye, Venus is just a point of light, but Galileo's telescope allowed him to magnify Venus enough to see its shape. And once you can see Venus's disk, then Ptolemy's Earth-centered model predicts that Venus, like the Moon, should show phases. To see what these phases should be, let's consider what we'd see in the Earth-centered system as we look from Earth toward Venus as Venus travels around its small circle. For example, in this position, we'd see a new Venus because the sunlit side of Venus faces away from us. Okay, your turn. These images show Venus at 4 positions in its orbit. Which image shows the correct set of phases predicted by the Earth-centered model? The correct choice is A. In the Earth-centered model, Venus always lies between us and the Sun. Sunlight therefore shines on Venus from behind as viewed from the Earth. At the 2 points where Venus is directly between us and the Sun, we see none of the sunlit side at all, which means we would see a new phase, much like a new moon. But even at the extreme points of its orbit, we would see only a small portion of the sunlit side. Therefore, in the Earth-centered model, Venus would never show more than a crescent. Of course, by the time Galileo built his telescope, Copernicus had already proposed an alternate model, in which both Venus and Earth orbit the Sun. This model also predicts phases for Venus, but the set of phases differs from those you would see for the Earth-centered model. Let's return to the view from Earth. Notice that Venus will again appear new in this position because the sunlit side faces away from us. Which of these images represents the phases that the Sun-centered model predicts for Venus? Choice D is correct. If Venus orbits the Sun, Venus will show a complete set of phases, from new through full and back again. Sunlight obscures our view of Venus during new and full phases, but through a telescope, you will see Venus in a crescent phase as it moves between us and the Sun, and in nearly full gibbous phases when it is on the other side of the Sun from Earth. Here are Galileo's sketches of what he actually saw. As you see, he recorded phases from crescent through nearly full. This is exactly what we expect if Venus orbits the Sun, but it contradicts the prediction of the Earth-centered system. We conclude that Venus goes around the Sun, not around the Earth.